Welcome back to Lift Right Academy. In this lesson, we are calculating sling tension when the sling at an angle and attached on the same level on the load. Let's break down case number 2. For case number 2, let's use this weight as an example. Here, the center of gravity is not at the center, meaning that the load weight is not uniformly distributed. The center of gravity is closer to sling L1. We have to calculate the length of L1 and the length of L2. For us to do this, we need to know the diagonal distance from L2 to the center of gravity and from L1 to the center of gravity. In calculation of the sling length, we cannot directly use 3.5 meter and 1.5 meter to get the sling length, because this L2 and L1 have to align to the center of gravity, and L1 have to align also to the center of gravity. And the hook block will be directly above the center of gravity. So the line of lift is a diagonal. And for the hook block to align with the center of gravity, we need to get the exact length of L1 and the exact length of L2. And for us to get the exact length of L1, we need to know this diagonal length. This is a plan. So let's call the length from L1 to the center of gravity. Let's call it D1. And the length from the center, the distance from the center of gravity to L2, let's call it D2. Now, for us to calculate this distance D1 and this distance D2, we need to use Pythagoras theorem. In a right angle triangle, Pythagoras theorem is used to calculate the size of the triangle. Right angle triangle is a triangle that has one of the sides as 90 degrees. Pythagoras theorem states that for a right angle triangle, C square is equals to A square plus B square. To get C, it will be equal to square root of A square plus B square. We need to apply the Pythagoras theorem here to get our D1. So let's consider this triangle as a right angle triangle. So using Pythagoras theorem, our D1 will be equal to the square root of 1.5 square plus 0.75 square. This will be equal to 1.68 meter. To get our D2, let's also consider this triangle. So this triangle here is also a right angle triangle. So D2 will be equal to square root of 3.5 square plus 0.75 square. This will be 3.58 meter. The 0.75 is half of this because this is 1.5. So half of it will be 0.75. So now we have the D1 as 1.68 and our D2 as 3.58 meter. Now we have to proceed to get the length of L1 and the length of L2. Since we have known the distance from sling L2 of gravity, and we have also known the distance from sling 1 to the center of gravity. Now to get the length of L1, L2 and the height h, we need to use another mathematical formula, which is trigonometric ratio, because we know this area and we know one of the angle. To calculate sling length L1 and to calculate the length L2 and height h, we need to apply trigonometric ratio. Why? Because we only know one of the side, which is D1, and we know one of the angle. We don't know h, we don't know L1, so we are gonna use trigonometric ratio to do this. If we have a right angled triangle, trigonometric ratio is used to calculate the other side of the triangle if we know two sides. If we know one side of a triangle and also we know one of the angle, we can use trigonometric ratio to calculate the other sides of the triangle. So to do this, we have a simple acronym, COG. So what does it mean? Sine will be opposite over hypotenuse, sine of the angle. Now where is the opposite? Opposite is the h, which is facing the angle. So h is opposite to this angle, and adjacent is d1, which is close to this angle, and hypotenuse is the longest side of a right angle triangle. For example, if I change this angle to this side, then opposite will become d1 and adjacent will become h. But right now our angle is here, so meaning our h is the opposite and our d1 is the adjacent. So for cosine, it will be adjacent divided by the hypotenuse, while for tangent it will be opposite divided by the adjacent. So we're going to use this, apply these ratios on this point to be able to get our L1. So our L1 is a hypotenuse. So what will work here will be cosine 60, which will be adjacent divided by the hypotenuse. So calculating for L1. So cosine 60 degree will be equals to the adjacent, which is 1.68 divided by the hypotenuse, which is L1. So making L1 the subject of the formula is gonna be L1 equals to 1.68 divided by cos 60 degree. So this will give us 1.68 divided by 0.5, cos 60 is 0.5, and our L1 is gonna be around 3.36 meter. Now we need to do the same for h. H here is the opposite, so which will work. So we can use tan 60. Okay, we can use tan, which is opposite over adjacent, because we have our adjacent and we are looking for the opposite. For h, it will be tan 60 equals to opposite, which is h, divided by the adjacent, which is 1.68 meter. So here I'm gonna cross multiply, so h will be equals to tan 60, okay, to then multiply by 1.68. So H will give me a value equal to 2.91 meter. All right, now I'm going to calculate for L2. Now we have our H, which is 2.91 meter, and our L1 now, which is 3.36 meter. So now we have this length, which is D2, and we have this height, which is H. Now this is forming a right angle triangle again, so we need to use Pythagoras theorem. To get L2, it will be the square root of D2 square plus H square. Now this will be D2 is 3.58 square plus H is 2.91 square. So I take the square root of all. When you do this expression, L2 will be equal to 4.61 meter. So now we have gotten our length for L2, we have gotten our length for L1, and we have gotten our height for H. Okay, so right now we have to now proceed to get the sling tension. So for us to now get the tension on L1 and the tension on L2, we have to use this equation. So for tension for L1, so we need to say T1, which will be W, the weight we are lifting, then times D2, which is the distance from the COG to sling L2, and then times L1, which is the length of sling 1. Then we divide this with the height of the sling times the sum of the two distances. Okay, these distances are from the diagonal we calculated earlier. All right, so T1 is gonna be 8 ton, which is the weight we are lifting, multiply by D2, which is 3.58 times L1, which is 3.36. Then all divided by H, which is 2.91 times, open the bracket, 1.68 plus 3.58, bracket close. Now if you do this expression, we are going to have T1 to be equal to 96 for the top one, divide by the bottom one, which will be 15.31. So this will be T1 will be equal to 6.29 tons. So this is the tension on leg 1. Now we will do the same for leg 2. T2 will be 8, which is the weight we are lifting, times D1, which is 1.68, times L2, which is 4.61, all divided by the height, which is 2.91 times, bracket open, 1.68 plus 3.58. When you solve this expression, the T2 will be, at the top it will be 61.96 divided by the bottom will be the same, 15.31. So T2 will be equal to 4.05 ton. So you can see that the tension on L1 is 6.29, which is much higher than the tension on L2. Why? Because the center of gravity is closer to L1. Alright, so if we want to select the sling, we need to add a consequence factor of 1.3. For minimum SWL we need, it will be the tension times consequence factor. So we use 1.3 as a consequence factor. So we need to increase the tension by 30% so that we can select a suitable sling capacity to lift this load. So for L1, the minimum capacity we need, the minimum safe working load we need will be 6.29 times 1.3, which is the consequence factor. So this will give us 8.18 ton. And for L2, the minimum capacity, which is the safe working load we need, will be 4.05 multiplied by the consequence factor of 1.3. So this will be 5.27 ton. So when we utilize a sling of 8.18 minimum and we utilize a sling of 5.274 for L2, then this will give us a suitable sling. The utilization will be less than 80%, which is very good. So in planning our lifting operation, this calculation is very important to be able to ensure that none of the sling is overloaded. So check in the store, choose any available sling that is the same or more than the minimum capacity as calculated. Thank you for watching this lesson from Lift Right Academy. If you find this helpful, don't forget to like the video, subscribe and turn on the notification bell so you don't miss any of our upcoming lifting and rigging tutorial. If you want me to cover more topics, drop your suggestions in the comments. Stay safe, live right, and I will see you in the next video.